Hello everyone. Today we will start solving the further questions on page 140 and 141. Question number 1. Kim and Sam are playing with a ball in the park. Unfortunately, the ball finishes up in the middle of a pond, out of reach. Kim thinks that hitting the water with a stick will make waves that will push the ball to the other side. Which two of these words best describe the waves that are created in the water surface? Circular, longitudinal, plane, pressure, and transfers. Here is Kim. She's hitting the water with the stick. So, as we know, the kind of waves will form. But what kind of waves do we have in water? It's transfers. So, here is the first word that describes what will happen. Another word that also will describe what will happen is the waves, the transverse waves, when it will form in the water, it will form as circles. It will make circles. So circular and transfer, it's the best two words that describes what will happen in the or when Kim hits the water. Now, B. Kim hits the water surface regularly so that waves travel out to the ball and beyond it. The question here, it says, what happened to the ball? Okay, when she will hit the water, the transverse waves it will form. When these waves it will reach the ball will what? Ball will oscillate up and down. So the answer for this first one, oscillates up and down. The ball will oscillate up and down. What's the meaning of the ball oscillates up and down? It means the ball, it will moves up, down, and so on. Then Sam throws a stick which hits the ball at P. This is Sam. He throw a stick. This stick, it hits the ball at this position. Okay, so Sam is successful at moving the ball across the pond. Kim is not. Explain why. The answer will be transverse waves produce only up and down motion. So what will happen when Sam throw a stick to the ball? So what will happen to the ball at this position? The ball, it will goes up and down. So when it will move up and down, so what will happen? Transverse waves will produce only up and down motion. C. Kim hits the water surface regularly with the stick 20 times in 10 seconds. Calculate the frequency of the waves. To find the frequency, we said the definition of frequency, it's what? How many times the wave it pass a specific point during or per second. How many waves pass a specific point per second? Now, what do we have here? We have 20 times during 10 seconds. Now, we want to find how many times in 1 second. So, how we will solve it? We will say frequency equal to 20 times over 10 seconds. The answer will be 2. So the frequency here, it will be 2 Hz or 2 Hertz. C. No, 2. The waves travel across the pond at 0.5 meter per second. So what do you think? What's this number? This number represents what? If you look at the unit, it says meter per second. That means this number, it represents the speed of wave. Okay, calculate the wavelength. Now, what do we have here? We have the speed and the frequency. We need to find the wavelength just by applying the formula of for waves, which it says speed equal to frequency times wavelength. If you will replace the words with the numbers at the end, you will have 0.5 over 2, which is equal to 0.25 meters. So the wavelength of this word in this water, it will be 0.25 meter. Question 2a. The wave in the shallow tank of water shown in the figure moves at 0.08 meter per second towards the left. How long does it take for the wave to return to the position XY but moving to the right? Here, as you can see, this tank, okay, there is water in it, and there is wave. It starts from this position XY, this position XY. So it says how long, if you know the speed of this wave, it's 0.08 meter per second. When it will move to this direction, how long will it take if it will comes to this direction and then it goes back? Okay, here, what do we have? 0.6 meter, it means the distance. Now, what do you have to find is you need to find the time. How long will it take? So what we will do, the formula here, it's what? It's time. How we can find time? Sorry. Time equal to distance over speed. Now, how much is the distance? The distance, it's given here, it's 0.6 meter, but this is from where? From this point to this point. But the total distance is how much? It's this direction 0.6 and another 0.6, because it says when it goes to the left, the wave will move to the left and it comes back to the same place. So here the distance will be 0.6 times 2 over the speed. It's already given here, so the speed is 0.08. If you will solve it, the answer will be 15. 15 what? 15 seconds. Again, I'll explain it. Here you have this tank, it has water in it. This water, there's a wave in it. This wave, it will move to this direction and it goes back by this direction. Now, the speed of this wave, it's 0.8, okay? And the distance from this point to the end of this tank, it's 0.6. Now the question, it says how long it will take the wave to move to this direction and to comes back to the same point where it start moving. So as we said it before, the time the formula to find time, it's equal to distance over speed. Now the main idea of it, it's what? It's the distance. The distance here, it's already given, it's 0.6 meter, but this 0.6 meter, it's only the distance from this point y to this point, but the wave, it will move from this y to this point, and it goes back again. So 0.6 plus 0.6. So the distance here, it's 0.6 times 2, because one 0.64 going and one 0.64 coming, and the speed, it's already given here, it's 0.08. If you will divide, first you will multiply 0.6 by 2 and you will divide it by 0.08, and you will get the answer will be 15 seconds. Next question, B. A man is cutting down a tree with an axe. He hears the echo of the impact of the axe hitting the tree after 1.6 seconds. What sort of obstacle could have caused the echo? Here, what do you mean by it? There is someone, a person, he is cutting. This is a tree, and someone, he is cutting the tree. So he is using axe. So he heard an echo. So what do you mean by echo? It's sound. When sound waves, it hit a surface, a solid surface, and it will return back. So what do you think? What kind of solid surface we will have? So the answer will be wall. For example, let's say here, there will be a wall. So the answer for the first one, it's wall. The next question says, the speed of sound is 330 meters per second. How far is the tree from the obstacle? To solve this question, in the previous question, we said the obstacle, it was the wall. Now it says, how far is the tree from the wall? Some information are given. They said speed of sound, it's 330 meters per second, and he heard the echo after 1.6 second. Now, what do we need to find? We need to find the distance. How we can find the distance? We have the formula. We have the formula, speed equal distance over time. We need to find the distance, so we will just convert the formula. Now the formula, it's distance equal to speed times time. How much it's the speed? It's 330. How much it's the time? It's 1.6. So the answer will be 528 meter. But again, this 528 meter, it's what? It's the distance from the tool that he was using to the wall and come back again. Okay, so it's two distances. Now what we have to do, just 528, we will divide it by 2, we will get 264 meters. So the tree, it was far from the wall. The distance between tree and the wall, it was 264 meters. C. Distinguish between the nature of the sound wave in B and the water wave in A. The sound wave and So here we have two types of waves: sound waves and water waves. Firstly, you should distinguish between them. You should know each one what kind of waves it is. Sound waves, it's longitudinal waves, and water waves are transverse waves. So if you want to distinguish between these two types of waves, what you will say: sound waves are longitudinal and much faster than water waves. Question number 3, it says, the figure shows an oscilloscope trace for a sound wave produced by a loudspeaker. Copy the figure and draw the trace for a louder sound of the same pitch. Here, what you will do, you will draw this graph again, but this time how it should represent a louder sound of the same pitch. Now you should focus on these two words, louder and same pitch. What do you mean by same pitch? It means same frequency. So same frequency, it means the same number of waves. So but the sound here, it should be louder. When the sound will be louder, when the amplitude will be bigger. So what we will do, we will just draw another line same as this one but higher. Okay, now this sound, it's louder. B, it takes 1/50th of a second, or this number 1/50 is equal to 0.02 seconds. Again, the question says it takes 0.02 seconds for the whole trace to be produced. What do you mean by the whole trace? It's the diagram that it's shown, which it's two waves. Okay, now show that the frequency of the sound produced by the loudspeaker is 100 Hertz. Now, the whole trace, it's two waves. These two waves, they took 0.02 seconds to finish. But now, the question here is saying, show that the frequency of the sound produced by the loudspeaker, it's 100 Hertz. The frequency, what do you mean by the frequency? Number of waves per second, or over 1 second. Now, the two waves, they took 0.02 seconds. If we have one wave, how much it will take? Half of the time. So half of 0.02, it's 0.01. Now we will find the frequency, number of waves over second. One number of waves, how many waves? One, over time, how much time this one waves it took? So it's 0.01. If you divide 1 over 0.01, you will get 100 Hertz. Second question, it says, determine the wavelength in air of the sound produced by the loudspeaker. Note or hint, the speed of sound in air is 330 meters per second. So the question here, they gave us the speed of sound in air, and also we found the frequency. The question, it says, find or determine what is the wavelength. Firstly, we have the general formula, which says speed equal to frequency times wavelength. Now we can just convert the formula. The formula, it will be in this way: wavelength equal to speed over frequency. Now the speed, it's already given here, it's 330. You will divide it by 100, which is the frequency. You will get 3.3. 3.3 meter. It's the wavelength of the sound wave. Question number 8. A microphone is connected to an oscilloscope. When different sounds A, B, and C are made, these are the waveforms seen on the screen. So A, B, C. Now, questions. A. Comparing sound A and B. So we will compare A with B. How would they sound different? So what's the difference now between A and B? If you look at the waveform of A and B, you will see they differ by what? They differ by the amplitude. So B, the amplitude of B, it's more, or it's higher, bigger than A. So if the amplitude it's bigger, that's mean this sound will be louder. So now the answer for A, it's B louder than A. Again, the answer for A, it's B, sound B, it's louder than sound A. B. Comparing sounds A and C. Now we will compare these two, A and C. How would they sound different? Okay, now if you will look at the A and C, what is the difference between them? They differ by what? By number of waves. So number of waves, so what you will say, C higher, it have the pitch of C, it's higher than A, because number of waves it's more than A, so it means this, it has a higher pitch than A. Now C, it says which sound has the highest amplitude. How determine which one has the highest amplitude? We say, what do you mean by, or how, what's the definition of amplitude? We say it's the maximum point that the wave reach it from resting point. This is the rest point, okay, rest point and rest point. Which one it goes more? Okay, this it goes only one square, it goes one square, but this one it goes two squares. So which one has the highest amplitude? The answer is B. D. Which sound has the highest frequency? Okay, by the way, this oscilloscope now it's showing number of waves in 1 second. So here what do we have? We have how many waves? Okay, from here to here it's 1, 2, 1, 2, 1, 2, 3, 4. So if you will look at C, you will see it has the highest frequency. Why? Because here we have 1, 2, 3, 4. 4 waves in 1 second. 1 second. So the answer will be C. E. The speed of sound is 330 meters per second. If sound A has frequency of 220, what is its wavelength? How to solve this question? Okay, again, the question is asking us to find what? It's asking us to find the wavelength. So we will write wavelength equal to speed over frequency. Now, how much is the speed? It's 330 over how much is the frequency? It's 220. Okay, so 330 over 220, so the answer will be 1.5 meter, because we are finding wavelength, so the answer will be 1.5 meter. Now F, what is the frequency of C? To find the frequency of C, simply we can find it depending on the A. The frequency of A, how much it is? It is 220. 220 with how many waves? Okay, we have 1 and 2. Here it's what? It's 1, 2, 3, 4. 4 waves. Okay, so just what you will do, multiply 220 by 2. The answer will be 440 hertz. Okay, the rest of questions will be your task, so you should do it by yourself. If you have any questions, any concerns about it, please just text me, and have a good day.